Welcome to episode 3 of the Codepunk podcast. I am Bill Ahern. I'm with Michael Zuhl, the mastermind. Hey, Mike, what's up, man?
I don't know about the mastermind part. I get by. I get by on. Have you seen those developer? They're like fake O'Reilly covers, and one of them says "essential copying and pasting from Stack Overflow."
Yes, I love that. He was on a podcast I listened to. I can't remember which one. Maybe it was like Software Engineering Daily, but they interviewed that guy.
That's funny.
He said, it was good. It was a good interview. It was kind of some of his creative influences for those funny little things and stuff like that. It was good.
I mean, all of them are somewhat grounded in reality. I can't think of a lot of them off the top of my head, but I remember reading all of them and kind of chuckling because, I mean, they were pretty good and, tested in production and a couple of things like that.
Yeah. I mean, unfortunately for the audience, if you don't know the context, there's a developer and he made a bunch of like those fake O'Reilly covers for books that are more realistic. Like, the one is the one example that Michael used was holy crap, do it again. I forgot it.
Essential copying and pasting from Stack Overflow.
Right, yeah. And then it would have all the little animals on the covers. And they were all very clever and very pertinent to, what programmers really do in the course of a day, which is a lot of debugging, a lot of hanging out on Stack Overflow and trying to, paste your error messages into a browser and trying to figure out what it means.
I think one of the other ones was resume-driven development.
Oh, yeah. That is one.
Which is pretty hilarious. So one of the things that we didn't do at the last episode, and I meant to, was let people know where they can find us. I am on Twitter at twitter.com/Zuhl, SZUL, and Bill, you're on Twitter at twitter.com/Neurothustra, correct?
Yeah. That is a portmanteau of neurology. Not that I'm a neurologist, but I couldn't think of a good word that mixed with Zarathustra, the character from Thus Spake Zarathustra, the Nietzsche book. I'm a big Nietzsche fan, so I really couldn't think of a good way to combine Zarathustra and something else. So brains are cool. So it's neuro and then Thustra, one word, Twitter.
I believe it was back in 2004. I think it was late 2004. You had just gotten hired at Digimax Development. And we were sitting there, and we were using MSN Messenger at the time. And I'm like, Bill, what's your MSN Messenger?
I believe
Hotmail.com. And I'm like, what is that? Some combination of Neuromancer and Thus Spake Zarathustra? And you looked at me, you were like, you're the only person that's ever gotten that.
Yep. Yeah, it was Neuromancer. That's where it came from. See, it's been so long, I forgot. That was true. It was Neuromancer and Thus Spake Zarathustra. That's the original it came from. Yeah. Geez, it's amazing. The funny thing, I struggled. I didn't like that handle for a long time because people could never pronounce it, and I used it everywhere for everything. And for a while, I actually tried getting rid of it, and it's like all over the internet now. So it's kind of like, I'll just stick with it. But I still, even on Xbox Live, if I play with people and they see my name, I get Neurothruster all the time.
Which might be perfectly valid depending on what game you're playing. Right?
Yes.
Speaking of games, right? So last episode we talked about the physical world being modified by technology, and so this episode we're going to talk about virtual worlds, and we're going to talk about the potential of uploading human consciousness into a computer and what that actually would look like. And I know, Bill, you're a fan of this, and you pretty much would upload your consciousness immediately if you could, right?
Oh, there's no doubt. And I don't even say that in any kind of like snarky or silly way. I would happily shed the corporeal form for something that would exist in perpetuity with the ability, presumably, to continue to accumulate knowledge in a way that the human mind neurologically is not capable of.
Right.
But and we'll get into this later on. But you're going to touch on that, right? Like, we don't learn the way we're teaching computers to learn the way we learn, not necessarily that we try to learn the way computers learn.
Oh, absolutely, and we'll definitely get to that. As with it seems like most episodes, we touch a little bit on popular culture and cinema. And one of the influences for this episode is, of course, the Tron movies, the original Tron and Tron Legacy, which we're both fans of. And then a couple other television shows and movies. Black Mirror has an excellent Christmas episode that touches upon what your consciousness in a digital environment would look like. And it was a pretty good story where one of the, spoiler alert, where one of the main protagonists, which I think was John Hamm from Mad Men, he worked as a guy who basically trained somebody's uploaded consciousness into accepting the faith that they had. So it was an interesting ethical thing. And of course, another movie, which is a fantastic movie, is The 13th Floor, which dealt a lot with computer simulations. And we'll get into a little bit of those. But one of the things that Bill was talking about, and we'll definitely probably talk about this more and more throughout, is when we talk about the idea of uploading human consciousness into a machine. If you remember from the Tron movies, when that person gets digitized and they enter into the grid, into that world, they see a world that's somewhat similar to the world that we see. And there's a clip in Tron Legacy where Jeff Bridges' character starts talking about, I try to imagine what the grid would look like, where the pathways like highways, and he visualized basically what a city would look like. And of course, you get the traditional imagery of Tron, in which you have, at least in Tron Legacy, you had a lot of glass, a lot of very specific and artistic ways of looking at what a computer world would look like. And so Bill and I kind of were thinking about, what would it really look like? Would it look like that? Would it not look like that? And I've kind of fallen on the theory that if we were to upload our consciousness into a computer, you most certainly would visualize that world. And I say you visualize that world because if your consciousness is in there, your working memory or whatever is running, you will definitely start to interpret the things around you in the most familiar way possible, which is going to be how you see the world, in the here and now, in the physical world. So one of the things that Bill was talking about as far as how we design computers, and one of the I've gotten into, I have a degree in psychology, and I specialize in cyber psychology, human computer interaction, and I do a lot with online learning and things like that. And there's always one section of almost every single course when it starts to talk about technology and psychology, and it starts asking about this idea of the human brain like a computer, which is a terrible analogy that I absolutely hate when people bring that up. They start talking about the brain, and then they try to draw comparisons with a computer and how a computer works. And it might be a nice anthology, it's an anthology of stories. Yeah. It might be a nice analogy to use, but the reality is that it's not the brain that's like a computer. We're designing computers to be like human brains. And the reason why I say that is it's almost like, it's interesting because if you look at religion, you have this idea of God created man in his image. And as we become more of a technological race, we become more secular, and more people abandon the idea of religion. But it's almost like we're repeating, that story as we attempt to make machines more and more like us.
We're persisting it.
Right.
Well, okay, so to be fair, of course, my religious views are a little different, but I posit that the way that mankind has created his religion is, again, just a projection of his own. It's the way man sees himself. God is his own man because of the way God perceives him, or the way man perceives himself. So there's this projection, and that projection is God. And I say it's very consistent in the way that we create anything, the way we create, right? So we've created a God in our own image that in turn created us in his own image. And I know that this is not necessarily a belief of yours, Mike, too much, but we're doing the same thing now with technology, only it's a layer of abstraction because, of course, we don't have, in some ways we don't have the stark spirituality as much associated with the technology component of it, but it is still man creating things in his own image.
Absolutely. So we are at the point to where we are taking on that position of God. We are saying to ourselves, now we have the ability to create, whether we are creating things biologically. We're looking at cloning. We're looking at things like IVF. You're looking at the old science fiction idea of a baby grown in a lab, test tube babies. We're also looking at robotics. We're looking at androids. We're looking at artificial intelligence.
Yeah, machine learning.
We're the creators of those things. And the immediate tell is that we create essentially inefficient robots. There are a lot of things about human beings and human anatomy that if evolution had its way, I'm sure it would redo things. We're not the most efficient in many different areas, yet when we create androids, I mean, what's the first thing? We want to create an android that looks exactly like us and works exactly like us. Why the hell would we want that?
Right.
There are plenty of humans running around. Why create a robot that does the exact same thing? So, in science fiction, they're humanoid, and in real life, we're building them to be humanoid. And
that's the whole the anthropomorphization. I don't really know what the.
That is the correct term.
Yeah. Okay. So kind of creating these human-like inanimate things. Or I guess they are animate, but they're just not human, but they're human-like. It's funny to me too, because as we try to build them more human-like, we become a little bit more repulsed by them, and that's known as the uncanny valley.
Right.
And it's just funny to me that despite the fact that the general consensus is the more realistic they get, the creepier they get, but we continue to strive to make them more realistic. I just think that that's a funny paradox.
It's true, and moving away from robotics and into computers, trying to bring it more back to the here and now. Even the words we use, we say memory when we refer to the RAM inside of a computer. In fact, some people often confuse memory with hard drive space. Your everyday average person, so they're automatically looking at working memory and looking at stored long-term memory as virtually the same thing in a computer as it is in a human being. So when we sat down and we started to create computers and computing, we needed machines to do calculations like humans did calculations. So how would we need to do that? Well, we need a storage system. We need an ability to run, algorithms. So and what point of reference do you have to build something like that? The only point of reference you actually have is yourself, is actual human beings that are doing it. So the reality is that as we've created computers, we've done it based on ideas that we have about ourselves. It's a reflection. And that's why I don't like when we're saying, well, the brain's like a computer. Well, yeah, but in reality, we've been building out computers based on the knowledge that we have of the brain. And that's important because that happens throughout everything that we do. Like you said, we start seeing ourselves in everything, and we start building things to look like us, to work like us, based on our single point of reference. So when it comes to something like Tron, where you're inserting yourself into the grid, or you're inserting yourself into a virtual world, and you want to know what that world might be like. If your consciousness is in there, your consciousness is going to assemble that information in something that is most familiar to you. If we go to a philosophical debate, we can say that, there's the world out there and there's the world within. I mean, there's this idea of duality that we still can't solve. The world as it is, outside of how our senses assemble them, we do not know what that's like. You do not know what a wall actually looks like. You do not know what the sun actually looks like. You do not know what any of the objects in front of you actually look like. All you know is that your senses acquire information from the outside world, and they assemble them in a way that makes sense to you, that's interpreted by you. So if you were to take that and insert that into a machine, you would more than likely see the same thing occur as your consciousness reassembles all of this information into something that you can use. And that's why I kind of fall on the side of it looking almost similar to what it does in the real world. I'm not saying that it's created that way. I'm not saying that it actually looks that way. What I'm saying is that if you were to actually enter into a computer, you would see things that looked like the real world. And almost every science fiction story kind of follows along that similar path.
Right. And I wanted to kind of point out, too, that it also is based on the experience of the observer, right? So think about I'm trying to recall the name. I can't. But so Google just recently, I believe, open sourced its algorithm for image computation. And it was kind of popular some months back because they originally, when they were training it, they fed it tons of pictures of dogs. Right. So that every time it would process images, it always looked like these weird, almost like The Thing with Kurt Russell, like this amorphous blob of roughly dog-like faces, because up to that point, the algorithm's experience was limited to dogs, and it hadn't yet been exposed to a large enough data set to really contextualize anything beyond dog faces. Eventually, it would get there, but what it knew was dog faces, so everything was a dog face. And that's interesting, right? So if I wrote on how to correlate this to what you were saying, but I thought of that when we talk about, what we observe, the world around us. And if you have a limited pool of experience, that's going to translate in some way to what would happen if you went to a digital world. So here's my question, Mike. If somebody goes into a virtual world, we're going to assume that these things are constructed, right? We build them almost like a video game. You're going to build some space, some virtual space, and people are going to go in and experience the spaces that has been built. Or is there another possibility where we kind of create it and it's this sort of a world built based on the experience of the user? I guess that wouldn't be practical, would it?
Well, it depends, right? So what are some things that we know about the human brain, or at least how the human brain and how consciousness assembles things? What we know is that perception-wise, things get stored in different areas of the brain, right? So when we see stuff, how everything's being perceived. We're not just seeing stuff with our eyes and it's sitting there right in front of us. This is a collection of images that's affected by a collection of not just images but other sensations that's assembled within our brain, and it allows us to experience this worldview that we see right in front of us. It's not in one part of the brain; it's in multiple parts of the brain. And when we recall long-term memories, those memories are stored throughout, in different areas of the brain. It's not just localized. And there's a lot of things that we just don't understand of the brain at all. And we don't understand consciousness at all. So consciousness, what is it? Nobody knows what consciousness is.
Right.
Nobody can actually tell you what it is. And consciousness is what we use to perceive all the things around us and to acquire that I. Who are you? What is the I? So there are various theories on consciousness, and one of them is that consciousness is just essentially working memory. What is working memory? Working memory is like a buffer. So it's like
volatile, right? It doesn't really last.
It's just this thing that we've assembled in our current frame of mind in order to perform calculations, in order to perform reasoning. So it's our ability to maintain in our current mental state that which is going on around us, or that which we are thinking, in order to reason. Some people think that's all consciousness is.
Meaning that it's associative, right?
Yeah, but what is it and where did it come from? We don't know. It's right. The possibility was consciousness is an emergent event. And I mentioned an emergent event because if we look at Tron, there was the whole idea of isomorphic algorithms. Just this idea that these things, these algorithms that were not created by anybody simply appeared. Why did they simply appear? Well, they simply appeared because the moment was right for it.
Yeah, the conditions were right for this confluence of events to occur.
Right, which is highly possible, very similar to our own consciousness. So consciousness could have emerged simply because the factors were right for it to happen. You could be like Terence McKenna, who thinks that consciousness evolves because apes ate mushrooms, but
which would be hilarious.
They had this mind-blowing experience, and suddenly humanity evolved. When it comes to, is this a virtually created world, or are you experiencing, if we uploaded you and your consciousness, and what would that be? If we uploaded your consciousness, would that be its own algorithm? its own process of who you are. Once we determine who you actually are, an imprint of your mental state goes into a computer, and you are sitting there on a hard drive somewhere or within the working memory of the application itself, as the computer is booted. And what does that look like? What do those, what do all those electronics look like to you? What do those pathways look like to you? What does it mean if you're
right? How does it get transpiled? And and that's that right there. What you just brought up is the most interesting part to me. So I want to give a little context to what I'm about to say. And it's a question, really, that I'm about to ask. But I operated under the assumption for a long time that the brain worked like a computer, right? So all of my memories were in there somewhere, like a audio file and a video file, and under hypnosis and all this pseudo stuff, I would be able to recall all memories. All memories are accessible. And I was at a party several years back, and I happened to be talking to, actually it wasn't even several, so it just kind of shows how ignorant I was. And I'm somebody who loves technology and has a pretty decent handle on some of this stuff. Psychology, not so much. But I really thought that all memories were accessible because they were just sort of saved, right? Like a record. And so I was talking to, oddly enough, there was a guy there. This is all for a bunch of yogis, by the way. It's all yoga people. I was there with my then girlfriend, now wife. But one guy worked and he worked in this a town nearby, and he worked with, I think he was a computer engineer, and he was working with neurologists to help map, to basically build AI and to help understand how to map the data points, between, say, what is the difference between how a computer experiences things and retains that experience and the human experience, right? Literally all the stuff you're talking about right now.
Right.
And it's just funny, as we're talking, we're within earshot of another neurologist. So he's like an AI expert. She's a neurologist. So we all start getting into it. And one thing he had to correct me on was, no, you actually won't be able to just go back and recall specifically if you had a machine, right? Some sci-fi machine that could say, I want to know, what was I experiencing April 3rd, 1982? I thought it was possible perhaps to go and retrieve those memories. It is not. He said it doesn't. Your brain doesn't do that at all. It'll mash stuff up. And again, it's associative. It's kind of what your mental state was. And that's how the information, your brain isn't really there to record stuff. It's there to kind of gather information in some meaningful way to the individual. So it's going to be different for everybody anyway. We knew that. But that's sort of what happens is the memories aren't... retaining the memories as things happen aren't as crucial to the way the brain functions as it is retaining whatever salient bits of information and then using that.
Right. It's not a video recording. Your memory is not a video recording of what happened at that moment.
Right. And I was so bummed out to hear that. I will never know what I did April 3rd, 1980.
That information is split up, and it is stored in different areas, and it is stored, you're right, it is associative. It's stored relationally, and you have to reassemble those bits in order to recall those memories. That's why you remember.
My question is, what would, so say we get to a point where we're successfully uploading consciousness, right, whatever that is, sentience, what would those memories then look like? I guess it wouldn't really be, again, see, this is where I keep getting stuck on, all of my memories are on my brain like a hard drive. Even though I know that they're not, and I guess this is what you're talking about, putting it on a computer, you now have that sort of snapshot of your current emotional or perceptual state. But there's no, I wouldn't, Max Headroom, then be able to just start walking back through my past life. My memories, it doesn't digitize in that way. So what happens then? How would that look like? Do you have an idea?
Right. It would depend on the system that loaded you into the computer. If we don't recall something explicitly on our own, what do we do as human beings? A lot of times, you can develop false memories.
Oh, yeah.
Or you think that you said something and you didn't, or you think that you did something and you didn't. And you may walk yourself back across memory lane all you want, and you think you recall something in a specific manner, and come to find out you're wrong. And I think what would happen in a situation like that, and it's purely speculative and completely unscientific at all, with absolutely no evidence, but I would imagine that whatever part of you that does get uploaded into a system, if we assume it's your working memory, or if we assume it's an exact imprint of who you are at that moment, it would probably fill in the blanks for you. would it work like any other algorithm to where it'll make those leaps and bounds and try to fill in that information if you were to search over it? Would it be accurate? No. Would it be who you are? Maybe. There's a lot of holes to that, and there's a lot of obstacles to that. But what we're talking about isn't purely, isn't purely unscientific. I mean, this whole idea of human beings living in a virtual world. I mean, there's that theory of how do you know you're not currently living in a virtual world.
Right.
In our first episode, we talked about the Matrix, which of course talks about you being plugged into a machine and living in some sort of virtual world. There was a much better movie that came up at around the same time, and nobody watched it because they all saw the Matrix, and it's called The 13th Floor. I'm about to spoil this movie for you, so if anybody has not seen the movie yet, you can turn this episode off, go rent it somewhere, and then turn this episode back on. But in the 13th Floor, the general idea is that these people have created a virtual world in which they're able to, download their consciousness into it, and then a murder occurs within that virtual world, and then they need to go and investigate it, and everything like that. But the moment, so there's a moment later on in the film in which one of the scientists tells the main protagonist to go right ahead and go to like this, wherever you something about, and it's been a while since I saw the movie, so bear with me, but told him to go as far as he's ever gone before, drive as far as he ever could before in his life. And he reaches this point where when he goes out and he gets out of his car, wherever he was, and he goes and he looks, and he sees that it's basically broken up. He comes to the realization that he is, in fact, living inside a virtual world. So the concept of the movie ends up essentially being that there was a group who created a virtual world, but they never anticipated that within that virtual world, those people would also create a virtual world. And there's a long-held, Star Trek had an episode in which, they were on a holodeck and they had that Moriarty episode, and I don't know whether it was Riker or Picard who basically brought up, who knows, we could all be living in a holodeck simulation.
Right.
You really don't know.
And it goes back even to like Dream Within a Dream, because it's really the same analog. But X-Files had done it.
There are actual scientists who are investigating this theory, mathematicians, computer scientists, and there was one guy who was also on an episode of Through the Wormhole, in which they talked specifically about computer simulations and whether or not we are living in one. And he's an actual researcher who is attempting to figure out whether or not we are living in a computer simulation. And the basic idea is, if you as a civilization are able to advance to the point to where you can create a virtual simulation of a world and all its intricacies, and you do, and you will probably do that. And if the technology is there and if the ability is there to actually do that, how do you know that you are not actually the one living inside of that virtual world? And it brings in a lot of factors. If you look simply at a non-player character in something like Second Life, and you think of a more advanced version of Second Life or a more advanced version of any video game, you look at that and you say, well, that could never be us because that person is programmed to be that way. There's investigations in science today as how do you even know you have free will? How do you know you're not being controlled by the microbiome in your stomach that tells you what to do? We have parasites on us that influence our behavior. How do you know that your entire idea of free will is not just a bunch of learned responses?
Right. Because we don't live in a closed system where we aren't influenced by external things.
So it could very well be that you were programmed this way, that we are all programmed this way, and we are living in a virtual simulation at any moment. It would explain a lot of things, wouldn't it?
Yeah, it would. Now, I want to offer a little bit of an escape hatch for those whose minds maybe have been blown. And none of these are, we're not introducing any new groundbreaking theories. This is part of the way human beings examine their own consciousness. This is ancient stuff. But bear in mind, you always have, you can just pull the Occam's razor switch, which basically means that essentially you go with the simplest answer is usually the correct one. Not guaranteed, but typically the simplest answer is the right one. And that's really just a matter of reducing complexity. The more complex a thing is, the greater likelihood that it is prone to flaw.
Oh, absolutely.
Right. I mean, you want to say that as a sort of like, before you go all the way down that rabbit hole, Alice, just remember, in more ways than one, it's all in your head.
which is a good. It's actually a good point to bring up, since we're talking about things that could potentially all be in our heads.
So another question that I have is, we get to a point where clearly the biggest hurdle right now with getting consciousness from a biological entity onto a digitized one, presumably it'll be digitized, right? I mean, it's not going to get in computers any other way, is so that mapping, right? So if you can map in one direction, it would stand to reason you can map in the opposite direction. So now that we've got consciousness onto machines, will we be able to then kind of generate consciousness, breathe life into a machine, so to speak? I mean, is that realistic? Is that feasible?
Well, I mean, and it depends, right? Because it depends on what consciousness is. When we talk about artificial intelligence today, it's not exactly artificial intelligence, is it? Because when we think about artificial intelligence, we think about a machine or an android or something that can think on its own, and it has the exact same consciousness and capabilities, mental capabilities of a human being.
I've always been a little annoyed that we've appropriated the term AI to mean we've programmed computers to do things that we were impressed by.
Right.
Like, I can talk to it and it responds. It's AI. No, it's not. It's just responding to, it's programmed to do that. AI would not behave in a programmed way, at least as far as we can understand it.
So the biggest obstacle in that, so we can program a machine, we can program a piece of software to learn, and we can program a piece of software to learn every single thing it could possibly know about trucks, and we can even program that piece of software with only a couple of pieces of what to know about trucks, and it eventually assembles within its cache of intelligence every possible thing it could ever do about trucks, right? But it can't take that knowledge and apply it to a boat. So a human being could take that knowledge and they could go to a boat and say, okay, this boat is somewhat similar and I'm going to go and do all of these things. But generally speaking, the algorithms that we create and the machine learning that we create, the neural networks that we create, are not capable of making leaps from one piece of subject matter to another piece of subject matter without starting over from scratch, because it's a whole new scenario. So that's the greatest obstacle, I think. And we talk about consciousness, again, if we're ever able to identify what exactly it is, if we're able to determine what it is, and it has, I mean, if consciousness is an emergent event that occurs because of some quantum mechanical thing, we may never be able to produce consciousness in a machine if we're incapable of duplicating that quantum event. If it's purely a biological thing, if consciousness is this collection of signals that's set off by our DNA, will we ever be able to duplicate that? I don't know. And if you're religious and consciousness has to do with your soul, does a machine have a soul? So there's a lot of questions there. If all consciousness is working memory and some emergent mental state, then yeah, we most certainly could probably duplicate that in artificial intelligence. It's such a new field, and it's such a fantastic field to be in. But there's a lot of difficulties, mostly because we really don't understand our own brain enough.
Right.
We don't understand our own consciousness enough. We don't understand our own perception of reality or what reality is enough, that we're sitting here and making these leaps about this is what we know, so this is what we can create. And we don't actually fully understand ourselves yet. We're trying to create ourselves in a silicon image.
And, the thing is, and it's sort of true for a great many number of inventions that and innovations that humans have been responsible for, accidental. You said emergent serendipity. The environment was right, and somebody was doing something they weren't quite sure what they were doing, a scientist in a lab somewhere, and by accident, virtual reality or artificial intelligence. But I tripped over the word virtual reality because there's also the idea of what I've heard people posit, that what we have today is a virtual intelligence, which is to say that it's a sort of pre-programmed with limited heuristics, the ability for the thing to learn itself. Like you said, it can understand everything about a truck once you give it the parameters by which to learn about a truck, but it can't parlay that information, that knowledge over to a boat or a horse even, to understand that while a truck is, machinery and engine is not alive, a horse is alive, although people use it for transportation. You know what I mean? Machines wouldn't maybe necessarily be able to make that leap of logic. And for a long time, I maintained I never believed that artificial intelligence would actually ever occur. Artificial intelligence in the way that we talk about it, like, an actual living machine that, like, has some sort of emotional state. I don't know now. I don't know that I believe that that's impossible. And I don't know if that's a good thing. It doesn't matter. It's not a good or bad thing, I guess, really. I sort of feel like I'm seeing so much in just the last 30 years. Technology has advanced so much, and it'll level out, I think, and then we're going to have another sort of like what I was mentioning. Somebody's going to accidentally trip into something amazing. If we're lucky, it's because smart people are really figuring things out. We do have tools now. I don't want to go on a rant, but I want to make this point too. I was having a conversation about, somebody was talking about how the Department of, the American federal government, for the whole massive computer system they use for actual like federal taxes, like, income taxes every year, is like some ancient machine that's like running, I don't know, like COBOL or something, right? And it's really, really old and outdated. And, I was having a discussion with people. One guy is this sort of programmer. I mean, he is a programmer. And then there was another person who was she wasn't technology at all, but she's very, very smart. In fact, a lot of her area of expertise is teaching, like learning and teaching people how to learn, right? Like a teacher, but also teaching people. I forget the word. I can't remember the word for it. But anyway, it's that. She's basically a teacher who teaches teachers. How's that? And anyway, so the conversation came down to, I don't want to try and make this as simple as possible. I don't want to get long-winded about it. If a system works, there's no reason to update it, especially since it might take so much time to rebuild a newer system, to bring it up to spec. Right. And my argument to that, because I didn't agree with it, I'm very much pro the government should build new systems with new technology that's more secure, more safe. And the other thing was, well, if it's been working all this time, is it not secure? Is it not safe? Like, well, anything that's been around for a long enough time, the exploits are known, right? So it's just a matter if somebody can't get access to it. Maybe that's one thing. But, the tools that we have today, and this is where I'm going to connect it to the AI. I used to not believe AI was possible, but now seeing the way that we've developed tools, not only is it that we have the ability, like it's not just contingent upon human intelligence anymore. We have machines that can help us bridge that gap. And it's the same thing with old systems. You don't have to, it's not like somebody's rebuilding some massive archaic system anymore. You've got tools and technology that can help expedite that process, and something that might have taken 3 years, God, I don't even know when they built that system. Just imagine in the 60s, they built some massive database and computational system for federal income tax. What would have taken them like a year would take them maybe, a week now. And I don't, that's obviously I'm just pulling numbers out of the air, but the amount of time that's reduced by the significant advances in technology, especially in the last 20, 30 years, I'll say 20, it's amazing. And that's why I think that artificial intelligence is possible now, because not necessarily we're waiting for really smart people to step into it, but because people who are pretty smart have these amazing tools that can help get to that.
Absolutely.
I guess. I don't know. The idea of, and it's funny because guys like Elon Musk and Ray Kurzweil, that's my phone. Ray Kurzweil, Elon Musk, who's another big one? Brief History of Time, Stephen Hawking. They're all saying like AI. Let's not get in a rush to start building real AI. Let's slow that one down for a second here. So that's interesting to me. That was a little rambly, but it's kind of like trying to coalesce a lot of this abstract thinking. I think that I do believe that it's probably likely that AI can happen now, whereas I used to not. And the reason I believe that is because technology as a tool has given us such an amazing advantage.
Right. Well, I'm not in the same camp as Musk and those guys when it comes to artificial intelligence. I'm not dystopian about it. I honestly think that our dystopian look of artificial intelligence being created and wiping out humanity is just our own realization that humanity as a whole is just a terrible organism. It's a terrible, species, and we're projecting, and we're basically looking at it saying, well, if we were that artificial intelligence, we would certainly wipe ourselves out, because at this point in time, we're pretty terrible as far as creatures go. So I'm not in that camp. I think that artificial intelligence will actually help us. Where are we at in artificial intelligence today? We do have machines that can learn. We do have software that can learn, and it's certainly assisting. We have a lot of AI assist. When will we get to actual artificial intelligence? I don't know. It requires us to understand more about consciousness, or it requires something to emerge.
Right. No, I'm glad to hear you say that, because, again, I didn't really have a strong – these are people who have clearly, thought about it and working towards it on some level. But kind of what we were talking about in the last episode, where there is this natural intrinsic fear of the other. And here comes this thing that is like – smarter than us, presumably, right? Because it's a computer, and you have all these scenarios that people play out, like the Terminator, right? Like machines realize that humans inevitably want to destroy themselves, so they want to like expedite the process, and it's a little bit ridiculous, but at the same time, you want to wonder, like, well, since we have no idea about our own consciousness, and you're right, we project that fear and that unknown component onto this, these things that we would create. So I didn't really have a strong. I was like, how would that work? In terms of AI, like, would it be something that would assist us and aid us? And I actually, now that I'm thinking about it, I would more agree with you.
Well, think about it. I mean, demons want to invade our dimension and take over our bodies and soul. Aliens want to invade our land, and they want to enslave our people or destroy us or take over our bodies, and artificial intelligence wants to do the same thing. It's the same story over and over again that we tell ourselves in all of our science fiction and all of our horror tales and all of our religion and all of our culture of narrative. It's something that continuously reoccurs. So I'm not in that camp. I don't believe that artificial intelligence is going to be the detriment of humanity. I think that humanity is the detriment to humanity, and we're being quite effective at wiping ourselves out on this. But I guess that's it for this episode, unless you have any last words.
No, I think I've rambled enough.
All right, well, you can subscribe to us on iTunes, Stitcher, and Google Play. Again, you can find Bill on Twitter at twitter.com/Neurothuster. You can find me on twitter.com/Zul, SZUL. Of course, the website is codepunk.io. We put the podcast on there, and we put articles about technology on there, a little less digital lifestyle and cultural oriented like the podcast is, more pragmatic things. But you get a good sense of who we are and what we do. So we will see you next episode.